And welcome back. Now today we're going to look at this little tiny V.KEL module down here, which is in fact a Ublox GPS. Now this module is reasonably modern. I say modern, I mean I bought this in May 2016, haven't really used it. Now it's the beginning of 2017, but I thought now's the time to get this out. And why am I even looking at GPS modules? Well, first of all, I'm quite annoyed at the standard real-time clock modules that you keep having to change every time there's a daylight saving in force. So for example, in the UK we have to change it in March, then we have to change it in October again. 9 times out of 10 I forget which ones need changing and which don't. Luckily, I would say probably 90% of all the things in my house change automatically. So they obviously have got some kind of, I don't know, rugby transmitter type thing built in. Not a GPS I wouldn't have thought, but something that receives the long wave transmission of the time signal. Well, I haven't got access to that, not yet anyway. So I thought about using a GPS instead of a real-time clock. And there's the rub. This unit costs about £8, whereas a real-time clock will cost you probably about £2, less than that actually if you buy them 5 at a time. The DS3231 is my preferred real-time clock. It's accurate, temperature, what's the word I'm looking for? Temperature stabilized, so that the drift is minimal. So really once you've set it once using a computer or something, you probably don't have to set it again until that dreaded daylight saving time kicks in. So how about then using a GPS and just grabbing the time off the satellite? It's an option, isn't it? But not at £8 a time. However, there are different options. Let's have a look where I got this from first though, because you might be interested in GPS not just for the time, but for latitude and longitude and stuff like that. So let's have a look at my browser. Here it is. So this is where I got it from Banggood, but this particular module is available all over the shop. Now it says here £8.23 at the moment. £8.23, that sounds a little bit more than what I paid for it. I probably paid just under the £8 mark, was it, or around about 7 at the time, because this was pre-Brexit price. So once Brexit hit the wall, our pound value dropped. So it's a little bit more expensive now, but I should imagine the dollar price hasn't dropped. So let's have a look. Dollars, it is. Not going to tell me? Yes, it is. Oh, $10. Still pretty pricey, isn't it, for a real-time clock? But not necessarily, of course, for a GPS. However, there is an alternative, as I said. Now, if we look at AliExpress, there's this one, which is a slightly older module. Now, this is a Neo 6M. And I believe this one here is a Neo 7M. So it's a little bit more modern, and therefore the facilities are a little bit better. That is to say, it locks onto the signal a bit quicker. It's more sensitive, and I think I sort of go along with that really, because I've just turned this on about, I don't know, a minute before I started recording. The little green light here is either completely on or completely off, both of which mean I haven't yet got a lock. But within that minute it started flashing, which says I have got a lock, and it has to have a lock on at least 4 satellites before it's happy. So of course now it's very happy because it's got at least 4, and we'll have a look at the data coming out of that in just a sec. So the older one that I'm showing on screen at the moment, the 6M, might be a little bit slower in getting that lock. This is from switch on though, remember, so if you've got it permanently running, it will track those satellites continuously. Whether or not the one on screen is going to be as sensitive as this one, because remember I'm indoors at the moment, and yet it still managed to get the satellite lock no trouble at all. Something that my sat-nav seems to have trouble with when I bring it in to update the maps every now and again. So this is fine. This is good. I'm feeling good about this one, but I'm not feeling good about the price, if that makes sense. I certainly wouldn't feel happy using this as a real-time clock substitute. It just doesn't make sense, does it? Not commercial sense. £8 versus less than 2 probably. But this one on screen, $3.40. I think that I bought that, and that was £2.80. So we're talking perhaps a £1 difference between a real-time clock and this one on screen. Whoops, this one on screen, this older version. And I'm thinking, do you know what? For the sheer joy of not having to muck about, it would probably be worth it. but there's a gotcha for that as well, isn't there? Let's come on to that. In fact, let me show you the program that's running at the moment. So I've downloaded a library that's pretty well thought of in the microcontroller community, really. It's called TinyGPS. I think there's a newer version out, but anyway, TinyGPS it is for us today. It comes with various example programs, and I'm just running one now, so let's just have a look at that and see what we can see. Right, here it is running. Well, that's a bit shrunk, isn't it? Let me just expand that a little bit. Now, before anybody thinks, oh, this is great, I can read that data and find out where Ralph lives, I have to tell you, I've obscured the latitude and longitude on here, because whilst I've no qualms about letting people know where I live in general terms, that is in the UK, well, that's general enough. You can probably figure out some of the other things. But I really don't want suddenly being subscribed to several mail catalogues or whatever, because you just know that somebody's going to do that, don't you? So the latitude and longitude on here is not correct. I've obscured that. But apart from that, you can see it scrolling through here. Now this program is the initial sample program. It says here at the top, the sample. It just says, is this unit here working? Basically, is it actually doing something? Well, yes, it is, because we're obviously getting lots of data through. So let's just stop it scrolling and have a little look at some of that data. Right, let me expand this and shrink this down, which will give us a nice big view. There we are. Right, so what this is saying is all these ones beginning with $1 in the front, that's the sort of raw data coming out. Okay, and if you really want to understand all that, you can, but the TinyGPS library sort of abstracts that away from you a little bit. I mean, there's nothing magical about this. This is just pure text. You could look at all these and say, well, there's my latitude, there's my longitude, there's my vector heading or whatever. I can work it out. But as I say, the TinyGPS is a mature library and will do all that for you. So if we look at what the real data we're after here, it says latitude blah de blah 52 point whatever, longitude whatever, the number of satellites that it's locked onto, which says 4 at the moment, the precision, now that's a number between 1 and I don't know what, but it just means how accurate is that latitude and longitude, and it can be accurate down to sort of like a metre or two. Okay, well, for what I want, as I say, I'm not really bothered about that, but I have thought of a project that could make use of this. We'll come on to that later. The age means how long is it since I've had a fix from another satellite, and the chars and the sensors is just the data really. And then finally at the end where it says error, it's luckily for us 0. That's the checksum. So when it reads all this data, this stuff here, it obviously applies some kind of checksum to it. Probably the TinyGPS library does it. And says, is that correct? And lo and behold, we're lucky, it says, yes, it is. Now, if we take this latitude and longitude, for example, if I just copy that into the clipboard, we can just see where that's going to take us, really. So let me just copy that in. Let's bring up the browser and we'll go to Google Maps. Right, there's Google Maps. Now, this is in incognito mode, because once again I don't want it to start displaying lots of stuff about me necessarily. Let's paste that in. We'll take out that bit of text that we don't want. So that's the latitude and longitude, slightly obscured but undoubtedly still in the UK. Let's see where it says that is, and it says, so it reckons we're where that little red splodge is. That's not a million miles away from where I live, but you wouldn't find me there if you went there. So it is, in fact, I can tell you now that those latitude and longitude coordinates are uncannily accurate. I mean, it is as accurate as your sat-nav. And when I did it for real, it actually showed me where in my house I actually was, which is why I'm obscuring it. I just get a little uneasy about having all this accurate information floating about the internet forevermore. So accurate it is, it knows where I am, and that's fine. And obviously the date and time bit, which is what I want, isn't being shown here. We have to run a different program for that. And that's almost what I need to have a replacement for my real-time clock. So let's upload that. It's a slightly different program, so let me just find that in my environment here. So it's in fact this one here. Once again, I should say that I've obscured the output. In fact, you can see here where it says random C. That's where I'm randomizing some of the latitude and longitude information. However, that's not really what we're interested in, is it? Right, so here it goes zooping off. I'll just expand this window a little bit, make it a little bit bigger, because there's a bit more data coming out now. And now let me get rid of the workbench. Right, so what this is actually doing is displaying just about everything you can display. Good Lord, look at it, it carries on and on, doesn't it? Right, okay, so there we are. So that's pretty much everything that we can get hold of. So the first thing it's showing you in the extreme left-hand column over here is how many satellites it's locked onto. Now it did say 4 previously, now it's saying 5, and then 6 occasionally. So that's pretty good, given that I am indoors. You know, it's not bad, is it? HDOP, that's the horizontal displacement of position. Is it displacement of position? Not sure. But what it means is how accurate is this? And you could probably work out mathematically how many meters that meant you are within a radius of. Okay, who does that? Well, I think your GPS will do that. It says, I think you're here, and give you a little pinpoint, but you could be, you know, within a little circle of that. So that's what that's saying. Then you get the latitude and longitude. Now, as I say, these are constantly changing because of my obfuscation of that data, but they are normally very accurate. It does drift a little bit. I think it's about, the data sheet says about 0.2 meter drift or something like that, just when it's stationary. So in your coding, you would obviously have to cater for that. And talking of coding and catering for displacement, I'm guessing that these find their ways into drones and aeroplanes and other flying machines, or things that have to go out of physical sight so that you know where they are, or perhaps where they can find their way back to you. Okay, moving on then. Now you can see here there's the date and time. I'm just going to stop this auto scrolling now. You can see the date and time here, and that's the bit I want. I've actually changed this to DDMM, YYYY, but of course today being the 1st of January, it makes no difference at all. Happy New Year, by the way. And if you are watching this in August, well, Happy New Year to next year. So here's the date and time. Here's the data age, that is how long since it updated something on the actual unit itself, on here, which I haven't really got to grips with. The altitude. Now altitude, I think that means I am 86 or about. It keeps changing. There's quite a bit of difference there, isn't there? It means I'm about 85 meters above sea level. When I've played about with this and I've held this far above my head as I could and then brought it right down to the floor, it did change. But then again, having said that, it is changing here anyway, isn't it? So maybe that was inconclusive. But I guess you might want to know about that if you were flying a drone, how high you were. And if you were to then subtract the value that you first got before you set off, so at ground level, your ground level, it might say, for example, 84.5. That's your ground level, isn't it? Then you would know how high in relative terms you are when you're flying away. Okay, the course and speed from the card now. This bit up here, so we got the course is 0, which means I think that probably means I'm not moving anywhere. The speed, well, I'm not sure what unit this is in, but we're not going anywhere. We are stationary, so I'm guessing this is just a bit of noise coming along here. Perhaps it's in millimeters or centimeters or something, I don't know. Can't be anything else. Certainly not going to have a 2 mile per hour or 2 kilometer per hour error, I wouldn't have thought. We'll have a look at the data sheet a bit later on for that. And finally, you've got the cardinal, which is north. So maybe this is currently orientated towards north. I mean, if I change it that way, so that's a 45-degree turn now, would that actually change? Well, let's set the auto scroll back on. Oh look, it's gone to southeast now. Let me just turn that round upside down so it changes again. So it's upside down, and Still says southeast, doesn't it? Not quite sure when that changes then. No, because it's certainly not changing in real time there, is it? Perhaps we need to get the data more frequently, and this unit allows you to get the data up to 5 times a second, which is quite a lot. Now, what's the next thing? Now, this is interesting. You can compute a distance to a target. Now, the distance to a target in this test program was in fact London, but I've changed that. I've changed that to somewhere near-ish me. It's just a shop a mile or two away, actually. It goes, well, it can't be a mile, can it? Because it says 283 meters, in fact, and that's the heading I need to take, and that's the cardinal, so northwest. So if I go out of my house, turn northwest at that sort of angle, and walk for 270 odd meters, I should see that shop. So there we are. That's pretty useful, isn't it? And what else? The last bits are just a bit of admin. You know, how many characters I've received and how many sentences. And at the end here, it's the checksum failures. And I think that checksum failure, in fact, might be a accumulation, because obviously we haven't got a checksum failure at the moment because it wouldn't be displaying all this data. So I think there might be just something not quite right with this library, or perhaps it's designed to do that, to tell you how many failures you've had to date since you've switched it on anyway. Right, let's think about a couple of other things then. Now, I mentioned that I was going to use this, or I'd like to use a GPS as a replacement for real-time clock. But look what it's saying here. It's saying here the time is 17:53. Well, according to my computer, the time is 17:53. But come March the 20 whatever, Sunday, 25th, something like that, we'll go to daylight saving. Now this time displayed here is UTC format, Universal Time Coordinated, which means the whole world uses that as its basic starting point and then adds on whatever time difference they need. Well, that means I still, in my code, would have to say, when does British summertime start? When does it end? And at what time does it end, remember? And then either add or subtract. Well, no, not subtract would be fine. Once we come out of British summertime, I can use this value. But going into British summertime, I'd have to say, well, is it 2 o'clock yet? Add on an hour. Or is it 1 o'clock? You have to add on an hour. So, I mean, it's all these little things. But at least that's only one thing you have to do to get the current time. And unless you're actually standing over your newfangled project at 1 a.m. in the morning or 2 a.m. or whatever it is, you're not going to see it go wrong either. So this is simpler to get the date and time by all means, I believe, and you never have to set it. It'll always just run as long as you've got a signal. And as I say, because I'm indoors now, I'm hopeful that GPSs will be sensitive enough, even that cheapy one, to grab that signal. Now, I have ordered that cheap version of the GPS, this one here, but it's on a very slow boat from China. I mean, the stuff does take from China 4 weeks. Sometimes it can be surprising and just take a couple of weeks, but on average I think you're talking 4 weeks, by which time of course this chip will be even older than what it tells me it is down there. But once I get this chip, I'll be able to plug that in, and hopefully, does it come with a lead? Oh no, it needs a header. That's good. Got plenty of DuPont cables to connect up to that. So I'm going to test this down. Now if this gets a fix as easily as this one does on my workbench, within something like a minute of me plugging it in, I'll be well pleased, and I'll come back to you saying, I think we have a winner here. If on the other hand I plug it in and it won't get a fix until I've been outside or something, then we have a problem. And talking of which, here's another little gotcha. When I was playing around with this over the Christmas period, first time I plugged it in, nothing happened, and I thought, well, perhaps I need to put it by the window, which I did, and of course it started flashing within about a minute. And I thought, well, perhaps I need to put it by the window every time. Yesterday when I was playing about with this, it would not get a lock for love nor money, no matter what I did. And I reset it. Eventually I had to take it outside, which is why you're seeing a lead into this power pack here. Take it outside on this green mat, plug it in, put it on the roof of my car. I took the dog for a walk. He likes it. and when I came back it had got a lock. Having got the lock, I could then bring it indoors and it was flashing quite happily as it is now. Today I plug it in, it flashed straight away as it did the first time. So I don't know. I wonder if it's something because I've done. Because if you look on this particular unit, look, if I hold up the board, underneath that little thick splodge of blue, I'm pretty sure that's the antenna. And being underneath the unit like that might work okay. Maybe I should have flipped it the other way around. But there's a story to this which will probably make you smile. As you can see on here at the moment, instead of having trailing wires, I've got these soldered onto a piece of stripboard. Now if we just look at the browser again quickly, and that particular one's on here. So this comes with a nice little cable like this, it looks like a Molex connector there, or micro Molex, what do they call it, a blade, a Molex, tiny it is, but would fit in to this thing here very nicely. But as I bought this several months ago, I've lost this cable. I know, how can I lose it? My workshop is so tidy normally, but lost it I have. I hope I haven't used it for something else, thinking it was just spare. There's the thought. Anyway, the point is I've lost it. So, on that basis, we've had to make some changes to the way this is mounted, and I basically soldered directly onto the pins behind here, straight onto some stripboard, and then put a header on myself. Now that works all fine, and if you like, I was prepared to sacrifice this one onto a bit of stripboard. But given that this is stripboard, and if I take it off the blue tack that's holding it down at the minute, you'll see, of course, we've got lots of copper underneath now. So I'm thinking, is the copper actually stopping it receiving data? Because it might act like some sort of shield, mightn't it? Might do. Or is the data coming, straight from the sky down to this, through this unit onto here? I don't know. I'd have to read up a bit more about that. So maybe I've done myself a bit of a problem here by soldering it to the stripboard. Instead of, if I'd flipped it around the other way, it might have been easier. I shall find out in due course, no doubt. Now there is a rather nice data sheet. Well, I say sheet. There's a manual for this. Tells you absolutely everything you ever want to know about it. So let's bring that up and have a quick look. In fact, just before we shoot off there, let me just show you a very quick connectivity diagram, because I know that some subscribers on my channel have said, can we have a bit more detail on how you connect things together? Because I can understand that for beginners, you see this and you see lots of cables and you're thinking, well, what's connected to what and how is all this working? We'll have a look at the fundamentals of the code after we've had a look at the connectivity diagram. So here's how it's all connected, and we'll have a look at the code in just a second. Just before we have a look at the PDF of the datasheet, let's have a look at the connectivity. So you've got your Arduino, which can be Uno or Nano or something, whatever. And there's your GPS unit. It's only got 4 connections that we're interested in. So the receive goes to effectively 2 pins that are the reverse. So the receive goes to transmit goes to receive. Simples. Right, that's how you connect it up then. Very simple. And we'll go through what we mean by RX and TX in just a minute. But here's the data sheet that we want to have a look at. So this is it. Now this is completely about this particular module. Let me go back to the top. There it is. Look, that's the actual name of it, and it's exactly that one, the one that I have on my workbench at the moment. So, and it tells you everything there is to know about it. What I should have read, of course, is how to mount this, the orientation, because this antenna here, maybe that should be facing the sky rather than facing some stripboard underneath the unit. Should have thought, really, shouldn't I? But there we are. I was panicking a bit actually about losing that connector. Okay, well, I mean, I can buy some more of these units, and if they work out more cost effective, I might think about it. You can actually buy 5 of these from AliExpress for £30. That makes them about £6 each, but even £6, that's quite a jump from £2, isn't it, for a real-time clock? So I'll just keep a watching brief on that, I think, really. Now, there's lots of things it tells you about here, and blah, 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 blah. The one thing that I have been playing about with is the protocols for setting some parameters. Let's look in down here. Setting the baud rate, for example. when this unit arrived, it was set to 9600 baud rate. The TinyGPS library seemed to think it should be set to 4800, or maybe other GPSs are, I don't know. But I connected it up, changed the code so it said 9600, and it all sprang into life. Oh, the other thing you might have to do, by the way, is switch around your receive and transmit pins. If you've got all this set up and it just doesn't work, just flip around the receive and transmit pins, which we'll talk about a little bit in a minute. Okay, so you can set it to 4800. I don't know why you would. Why would you make it slower? I can see you making it quicker. And of course you can set it amazingly quickly. You can set it all the way up to 115, 200. But I thought, well, I'll try this out, because look at this long string you have to send the unit in order to do that. How do you do that? How do they really mean you to do that? Because you can obviously do other things on here. Look, all these disabling and enabling and all that. What else? You can tell it to how many outputs per second to give you. 5 outputs, that's the 5 times 1 output. 10. I don't think this does 10, although this is the data sheet, maybe it does. Okay. And of course the reset to manufacturer's defaults, which is always a good option to know about, I think, really. Okay, so that's all the things you can do to it. So how did I set the baud rate using this big long string here? And for that we need to look at the code window. So here's the code window with the standard demonstration program supplied with the TinyGPS library, just with a few changes I made to help along. Now, first things first, we're talking about connectivity. We're using software serial library. Now, software serial is a library that allows you to use any GPIO pins to support transmission and reception of data. By default, on the Arduino Uno and Nano, you'd have to use pins 0 and 1, but if you do that, then you can't connect it to a USB and have data coming back up to your serial monitor. So people tend to avoid that, and I do too. So hence software serial library, standard library that comes with the Arduino, and you can choose any 2 pins for the receive, first pin, and transmit. Now, if you're not ever going to send any data to this unit, changing baud rates or resetting it or closing it down or whatever, then in fact you don't even have to connect up the second one. You can just have a receive. You still have to specify it, but you don't have to connect it up. So basically you're down to 3 wires here rather than 4. But as I said, I did change the baud rate just to prove it worked. So how did I do that? Well, here we are. Look, I put all those numbers. If you remember those numbers in the data sheet, let's go back to that very briefly. So here's the numbers. Look, B6, 62, 06, and all this kind of stuff. Right. All I did was copy them in here, putting 0x in front to say this was a hexadecimal value. Put it into an unsigned char. Has to be unsigned so you can get the full 255. Otherwise, some of these won't fit. This is an array. The square brackets means it's an array, and the squiggly brackets are an initializer, so these are the values. So we're declaring this array with all these values in it, and then we're having a little loop here. Now you see I've commented this out at the minute because I didn't want this to actually run every time. So if I just uncomment that again, so what this is actually doing, I'm saying for the size of this hex char array that we've just added all these values in, rather than counting all these values, we just say size of, however big this is, in other words. All right. So we're saying starting from 0, which is the very first one. Everything starts from 0 in computers. As long as the count is less than the size of, remember it's always -1 effectively, so not equal to, it always has to be less than, and we'll increment the count, and then we just write down the software serial port, so it would be using that transmit, the value, and that's all it does. And then lo and behold, it all starts transmitting from this point at 4800, which is why then you have to say start my software serial at 4800 baud rate. Otherwise what you get back is gobbledygook, and you just get lines of asterisks. So I've tried that, it works, and then I immediately unplugged it, replugged it back in again, and it hadn't saved it, because there is in fact a save command on that data sheet. So right down the bottom it says save the changes. Now I didn't try this because I think if you were to execute this as well, it might write it into sort of some permanent memory on the GPS unit to say I actually want 4800 forevermore. There must be a way of doing that. I'm guessing this is the way to do it, but I wasn't going to risk bricking my unit just yet, so I left that as it was. And when I unplugged it and reset it again, it just ran back at 9600. Hence me commenting out that line there, because that basically doesn't do anything now. Doesn't write anywhere, and therefore I don't need the 4800. But that's how you do it for all of them. There's a reset, board change, setting various protocols on and off. Whatever you want to do, that's the way to do it. You're just transmitting down that software serial line. So the transmit on here, whichever one, it's the second pin on that declaration. So where you've got here software serial 3 is the transmit, and that will go to the receive on here. And there's a little tiny R down there. And that's the receive, and that's how it works. But if you're never going to transmit to the unit, you don't even have to connect that wire up. You just take the output from here straight into the receive here. So transmit from here to receive here. That's the first pin on here, and I've got it as pin 4, and you're good to go. Now the project that I said I had an idea for this particular unit, this expensive unit, came about for two things really. One is that my wife can never find a car in the Tesco car park. And secondly, when we went to Florida once, we actually lost our car. And if you've ever been to Florida, Disney World that is, the car parks are basically the size of, well, Milton Keynes really, where I live. Oh, shouldn't have said that, shouldn't I? Never mind. Anyway, the car parks are so ginormous. And if you go to the customer relations window, whatever they call it over there, and you go, I can't find my car, they go, wait until everybody else has gone home, then the only car left, well, the only 28 cars left are the ones that the people couldn't find them. So they've got not a lot of sympathy really. So I thought, this could be useful if you were to build this as a proper project, and then you're in your car, and it can be battery powered because you won't be using it for a long time. When you get out your car, you press a button, right? So fine, and it can say, great, I know where you are because I'm a GPS unit. I'll store that in my EEPROM somewhere in the Arduino, right? Here we are. I'll store that. When you then come out of the shop or whatever, the shopping mall, and the wrong exit, and you don't know where the car is anymore, you turn it on, you go find, next button, and it goes, I know where I am now, and I know where you want me to be, because I'll read that data from the EEPROM. That is in a cardinal direction of southwest, so it's sort of that way, and it's 296 meters basically. And you go, great, I can find my car. And I mean, it doesn't have to even be that accurate, does it? As long as it says it's over there about 250 meters ish, you're probably going to find it. And if you think about my NeoPixel 12 LED circle that I had as a project just before Christmas for my TV simulator, that would probably be enough to give you a direction actually. So the only addition I'd need apart from all this, and that NeoPixel of course, is an electronic compass, which are quite easy and cheap. So I might be looking into that as a project, but as you know, me and projects few and far between. They take forever because I'm doing all these videos. Still, it's an idea, and I've written it down, and I might well move that forward over the forthcoming weeks and months. Right, and when that cheapy unit comes in, which I hope it will do. Where are we? Not that one, the cheapy one, that's the expensive one. That one, when that comes in, I'll let you know as well whether or not it's as sensitive as the one we've got at the moment for picking up these satellites indoors, because I think there's definitely room here. But that's all in the future. I hope this has been useful and interesting. Certainly I've had a lot of fun with this, getting it going, not least trying to solder up all these little tiny wires. That was a joy, I can tell you. Okay, I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.